Alright, y'all, algebraic reasoning TEKS test is tomorrow. Okay, so let's get started. It says, given the pattern below, how many circles will be in the 7th stage? And B, write an equation to model the best pattern. Guys, build a table on patterns and always realize they start at 1. Okay, 1, 2, 3, 4. Not at 0. Okay, so this has 3, 5, 7, 9. So then you can use stat. Okay, clear my calculator. Could do stat, enter. 1, 2, 3, 4, 3, 5, 7, 9, and you'll do stat right. We're going to try linear, see if that works. 2x plus 1. If I plug in 2x plus 1, let's see if it gives me this table. 1 and 3, 2 and 5, 3 and 7, 4 and 9, and at 7 it's going to be 15. So in the 7th stage it's going to be 15 circles, and we said y equals 2x plus 1 is our equation. This one. Okay, this next one says write the equation of the line that passes through all given points. Again, let's do it in stat. So second plus 7, 1, 2. Stat, enter. Negative 2. I'm typing just the x's right now, and now the y's. 6, 2, negative 2, and I'm going to do stat right. Let's test linear first. So this gives me negative 2x plus 2. Negative 2x plus 2, second graph. Let's see if these points are in there. Negative 2, 6, 0, 2, 2, negative 2. So that's my equation, negative 2x plus 2. Okay. And then this next one, negative 3, I'm just typing the x's, and now the y's. Negative 1, 1, 3. Hold on just a second. Okay, so you'll put them in stat, and we're going to go ahead and do linear again. So stat right 4, enter, 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 and this gives me this. So I want you to realize that 0.6666 repeating is a fraction. So we know it's going to be something x plus 1 because of the plus 1. So 0.666666 repeating, math, enter, enter, it's going to be 2/3. So let's type that in our y equals 2/3 x plus 1, second graph, and see if those points are in there. Negative 3, negative 1, 0, 1, and 3, 3. So that is my equation. So y equals 2/3 x plus 1. Okay, so it says Susie receives a $100 gift card from Barnes & Noble for her birthday. Every time she buys a book and uses her gift card, she spends $11.50, and that includes the tax. So it says write an equation to represent the situation. Okay, so y equals, she started with $100 and she was spending, so taking away, so subtraction, $11.50 per book. That's why the x goes there. Okay, so it says what would be the domain of this function? Well, guys, you can graph it. 100 minus 1150x. Hit graph. We're not really going to see it because it's way up at 100, but you can see it's linear for the little piece we see. And I want you to realize that it's going to keep getting wider and wider. So for this, the function, which is talking about the equation, my domain is negative infinity to infinity, or all real numbers. Okay, while if I'm just talking about the situation, I'm talking about how many books I can buy. So if you start at 0, can you buy 0 books? Yes. Okay, so you can buy 0 books. Can you buy a half a book? No. So we can only buy whole numbers, so it's going to be a list. 1, 2, 3, 4, 5, 6. And if I keep going, I can buy 7, I can buy 8. But if you look, can I buy 9? No, because I would need 350 more, and I don't have that. Okay, so that is my domain of the situation. This is the difference between a situation and just the function, the equation. Okay, so the function means equation. Okay, let's look at number 4 through 7. Okay, guys, use your, what's it called, calculator to help you with these. So let's just start with the first equation. 3x to the 3rd power minus 4. Ooh, sorry. Okay. let's see if the table matches. So I start at 0, 0, negative 4. That's 0, 3, 0, 2, 0, 4. So this has 0, negative 4. So let's see if this matches. So 1, negative 1, 220, 377. So it does. So this goes with this. So this is y equals 3x cubed minus 4. And because it's cube, it's a cubic graph. Okay. So let's try another equation. 4x minus 3, which is this one. So I need 0, negative 3. This has 0, negative 3. The other ones don't. It says 1, 1, 2, 5, 3, 9. So this is this one, which is linear. You can even graph it, guys. Hit graph. It's a straight line, which means it's linear. Okay? So if you want me to look at this one, 3x to the third power minus 4, if you hit graph, remember this is cubic when it kind of does a little squiggle in the middle. Okay, so let's type our next equation. 4 times 2 to the x power. Okay, second graph. This has 0, 4. Neither of those have 0, 4, so that's not it. 4x squared plus 3, second graph. This has 0, 3. This has 0, 3, 1, 7, 2, 19. Okay, so that's this one. Okay, and this is quadratic because it's squared. Again, you can hit graph. It's a U shape, therefore it's quadratic. Okay, so I use that equation. If you notice, this one grows really fast, so it's probably going to be one of these two equations, so let's look. 4x to the third power minus 3, second graph. This has 0, negative 3, this doesn't, so it's not that one. So then let's try this last one. 2 times 4 to the x, second graph. Okay, so this is 0, 2, 1, 8, so there's my equation. Y equals 2, 4 to the x power. Remember, x power means exponential. X in the x power means exponential, or you can look here. This is an exponential graph. Page 2. Okay, linear data has a constant first difference, or we call this a finite difference. Okay, quadratic has a constant second difference. Cubic has a constant third difference. Exponential data, remember that's when you're multiplying, has a common ratio. Okay, linear is a straight line. Okay, you could type these in your calculator, so I think it's this one. And you could type these in your calculator to look, but I'm just going to talk about parts of an equation. So quadratic means something squared. A has something squared. Cubic has something to the third power. This is the only one that has something to the third power. Exponential has x as an exponent. Okay, so that's D. Cube root is cube and a root symbol, so that's I. Absolute value, remember that's the bars. So this is F. Okay, and rational. Rational means x is on the bottom of a fraction. It's a rational, however you want to remember it. Okay. Okay, now quadratic is a U shape, so it's I. Cubic is the squiggly, but it's a tall squiggly, H. Exponential is B. Square root is F. Remember, it kind of looks like a quadratic, but it's missing half of it, okay? Cube root is like cubic, but sideways. Absolute value, V for value. Rational, I always think of a fraction. Okay, so it's got something on top and on bottom, C. Logarithmic is this one. It's kind of like a sideways L. And linear is a straight line, E. Okay. The graph at the right shows h, the height in meters of a model rocket. Okay, this is what would be an appropriate domain for the given situation. So domain, it starts at 0. It took off from about 3 foot tall or 3 meters high, and it landed right here before 4.5. So I'm going to show you both ways to write it. It would be 0, we'll say 4.4, 0 to 4.4 with brackets because it touches, or from 0 is less than or equal to x is less than or equal to 4.4. Okay, what would be an appropriate range? Well, the lowest point is here when it hit the ground at 0. The highest we'll say is 17. So again, like this, 0, 17 in brackets, or 0 is less than or equal to y is less than or equal to 17. Okay. 26. This is never going to quit getting wider, so my domain is negative infinity to infinity. My range is my height. It goes down here at negative 9 all the way up forever. Okay, remember this could also be all real, and this could also be y is greater than or equal to negative 9. Okay, x-intercepts are where it touches the x-axis, negative 4 and 2. Remember, x-intercepts are where y equals 0, y-intercepts are where x equals 0. My y-intercept is here at negative 8, so 0, negative 8. Okay, domain here again, it's never going to quit getting wider, so it's negative infinity to infinity, or all reals. Ooh. Okay, and then my range is going to be from negative infinity all the way up to 6 with a bracket because it touches, or it could be y is less than or equal to 6 because it's open downwards. X-intercepts are where it touches the x-axis, negative 5, 0, and 1, 0. Y-intercept is where it touches the y-axis. Remember, that's where x equals 0 or y equals 0. Last but not least, domain. This one's domain is a little different because it doesn't go left forever. It stops at negative 4. So negative 4 to infinity because it goes right forever. Or we could say y is greater than or equal to, or sorry, x, because we're talking about domain. X is greater than or equal to negative 4. Our range is your height, so that's negative 2 to infinity. Or we could say y is greater than or equal to negative 2. X-intercept is 0, 0, which is also my y-intercept, because that's where the x and y axis cross. Now it says, which of the functions have the same domain? So this is all reals, and this one's not. So it's 26 and 27. Okay, if f of x and g of x are inverses, and this is f of x, then what's g of x? So let's flip them. So the first point would be 5, negative 3. Then it would be negative 2, 0. Negative 7, 2. And the last one would be 2, 4. So we just flipped all the x and y's. The negatives and positives stayed the same. Now it says, for the function f of x, we have this and we have this. Determine whether f of x and or g of x are inverses. Sorry, I couldn't read for a second. Negative 5, 2 flipped would be 2, negative 5. Is this 2, negative 5? No. So these are not inverses. We don't even need to keep checking because not perfectly flipped. There were sign changes. Okay. The function f of x and g of x are shown on the graph. Our f of x and g of x inverses explain. So I'm going to explain with tables. So we'll have this be f of x, and then we'll have, x. We'll have this be g of x. So here's a pretty point at 0, 1. The opposite of that is 1, 0. 1, 0, which is here, which worked. Then we have the point 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 9, and the opposite of that would be 9, 1, which also worked. So this is a yes. They are inverses. Oh, sorry, there's my table. F of x and g of x are inverses. Fill in the table. So remember, we're just going to flip them exactly. Negative 11, negative 2, negative 8, negative 1, negative 5, 0, negative 2, 1, 1, 2, 4, 3, 7, 4. So we just flipped all the x and y's. Values of a function are listed in the table. Is the function f of x equals 3x plus 2 an inverse? Well, let's look. So let's build our inverse table. Okay, so it would be 2, -4. I only need at least 2 points. 1, -1. Okay, so 3x plus 2, second graph. So I'm going to look, do I have the point 2, -4? I do not. Do I have the point 1, -1? I do not. Therefore, no. And this is kind of my explanation. Okay, so we're going to graph inverses, and again, we're going to use tables to help us. Okay, so here's my original. We'll say f of x. So we have, I'm just going to do 3 points. This point, and this point. So this point is -1, 5, 0, 2, and 1, -1. Okay, and my inverse of that would be 5, -1, 2, 0, and -1, 1. So let's plot that. 5, -1, 2, 0, -1, 1. So then we can draw our straight line. And there is my inverse graph. Okay, again, let's do this one. I'll call this one g of x. So we have 0, 0, we have 1, 1, we have 3, 2, we have 6, 3, we have 10, 4, and we have 15, 5. So the inverse of that, we'll build over here, would be 0, 0, 1, 1, 2, 3, 3, 6, 4, 10, and 5, 15. So 0, 0, 1, 1, 2, 4, or 2, 3, sorry. 4, 10, oh, sorry, 3, 6, 4, 10, and 5, 15. Okay, here we'll plot a few points. There's a pretty point. This one looks pretty good. This one looks pretty good. See this one? So we'll call this says f of x, so we'll just say f of x. X and f of x. So this is -4, 3, -3, 1, 0, 1, -1, sorry, and 5, -3. Sorry, that's supposed to be like the inverse thing. Okay, so flip them. That gives me 3, -4, 1, -3, -1, 0, and -3, 5. So let's plot that. So we have 3, 3, -4, 1, 2, 3, 4, 1, -3, 1, 2, 3, -1, 0, and -3, 5. And there's my inverse. Remember, they're flipping over the y equals x. Okay. To make his spending money, Dawson washes cars. He charges $10 per car. So y is the money, x is the number of cars, so y equals $10 per car. So, because he didn't have a starting point. So then it says to figure out how many he washed for $220. Well, 220 is my y, money is my y. So we're looking in the y column for 220. And that's after washing 22 cars. Okay, so then it says now find the inverse. Well, remember, we flip my x and my y, so it's x equals 10y. Divide by 10, divide by 10 to get y by itself. I get y equals x over 10. So there is my inverse. And we could always check our work with that in the calculator. Okay, now on to number 39. Describe what you know about inverses regarding various representations. So graphs, we know that it flips over y equals x. Tables, or ordered pairs, same thing. We know that X and Y trade. Here we know that domain and range also trade. Okay. Last page. Okay, so G of 3, guys, we can do these in our calculator. Type this in Y1, this in Y2, this in Y3. Negative 2. Always label if you're going to type more than one equation at a time. Negative 3 x squared plus x and 1/2 x squared plus 1. Second graph. So this says G of 3, so I'm going to find where x is 3. And I'm going to find G, which is in Y2. So the answer is negative, sorry about that, negative 24. Okay, now I'm going to find h of negative 1, so go back to x, find negative 1, and I'm going to h, which is on my y3, so that's 3 over 2. Now I need to find f of negative 6, so let's go to negative 6, and f is in y1, so this is 9. Now it says find x, so x, find, remember f of x just means y equals negative 5. So in the f, I'm looking for, f is in y1, I'm looking for negative 5. So there's negative 5, my x is 1, x equals 1, there's that one. Here I'm looking for 3 in my y3. Well, if you notice I have it twice, and that's okay because it's quadratic, so it's shaped like this. So I have it at 2 and negative 2. Okay, and then I have it again negative 9 and y1 because it says f of x, which is at 3. Now it says write a function q of x to represent g of x plus f of x. So we know q of x equals g of x, which is negative 3x squared plus x, plus f of x, which is negative 2x minus 3. Combine our like terms, which are just these middle two, and this equals negative 3x squared minus x minus 3. Okay, you could type this in the calculator, type this in y1, this in y2, and see if they match. Okay, here it wants us to find f of x and g of x, adding and subtracting. So I'm going to turn this off. Okay, so we can do this in our calculator. We can type 0 plus 1 because f of x plus g of x, this is f of x, this is g of x, so 0 plus 1 is 1. You could always type these in your calculator. 2 plus negative 1, 2 plus negative 1 is 1. 4 plus negative 3 is 1. 6 plus negative 5 is also 1. Okay, now let's do g minus, f of x minus g of x. So 0 minus 1 is negative 1. 2 minus negative 1. 2 minus negative 1 is 3. Remember, it's the same as adding. 4 minus negative 3 is 7. And 6 minus negative 5 is 11. Okay. Now it says, given f of x is 2x squared plus x, 2x squared plus x, and g of x is x minus 3, so this is in y1, this is in y2. Let's fill in these parts of our table. So 66, negative 9, 28, negative 7, 6, negative 5, 0, negative 3, and now it says add. So we're going to do 66 plus negative 9. It's 57. 28 plus negative 7 is 21. 6 plus negative 5 is 1, and 0 plus negative 3 is negative 3. So if I were to write these as ordered pairs, we take our x comma h of x. So negative 6 comma 57, negative 4 comma 21, negative 2 comma 1, and 0 comma negative 3. And now it says the length of two fences can be modeled by f of x equals 8x plus 3 and g of x equals 11x plus 1, where x is the length of a piece of fencing material. Write a function to represent their combined length. Combine, if I'm combining something, I'm adding something. So we're going to have 8x plus 3 plus 11x plus 1. So we're going to add like terms. 8x and 11x is 19x. Positive 3 and positive 1 is positive 4. Okay, last problem. Guys, do these in the calculator. Okay, h of x divided by g of x, so 2x squared plus 5x minus 3 over 2x minus 1 equals x plus 3. So we're going to plug this side in y1, this side in y2, and see if they match. Alpha y equals enter. 2x squared plus 5x minus 3 over 2x minus 1. We're going to see if that equals x plus 3. And they all match, therefore this is a yes. So we're going to circle it because it is true. Here we have h of x, 2x squared plus 5x minus 3 plus 2x minus 1 equals 2x squared plus 3x minus 4. So let's plug this side of y1, this side of y2. Draw a line to separate. So we have 2x squared plus 5x minus 3 plus 2x minus 1. And let's see if that equals 2x squared plus 3x minus 4. Second graph. They do not all match, therefore this is a no. And last but not least, f of x times g of x equals h of x, which is 2x squared plus 5x minus 3. So in y1, we'll type x minus 5 times 2x minus 1, and we'll type h of x, 2x squared plus 5x minus 3, and they do not match, therefore this is not true. Alright guys, test is tomorrow. Come in ready to go. If you have any questions, you can ask at the beginning of class. Have a good night.